Now I'm going to introduce functions. But first, let's start at looking at an issue. So let's say that I want to write my own code to calculate the square root of a number, and I want to use that code in multiple places. Now the math library has a function for doing this, but here I'm trying to demonstrate a point. So this actually uses Newton's method for finding the roots of an equation. So we start here with this threshold value, and what that is how close do I want my square root to be to what I really think it should be, right? And a is the number I want to find the square root of, so we know the answer to that should be 8. And then I start with an initial guess of x, and then I have a loop here that cycles through as long as the absolute value of the difference between x squared and a is greater than some number. So initially it's 1 times 1 is 1. 1 minus 64 is negative 63. The absolute value of that is positive 63, which certainly is much greater than this. So what I'm trying to do is get something that's really, really close to, in this case, 8. And once it finally reaches that point, the loop stops and it prints what the square root is. And then I want to reuse that code, and now I use b. And because I use b and I have to use z for this guess, every place I'd had x, I have to come in here and use z. And every place I had a, I had to use b and hope that I didn't make a mistake, and I found every place where I used it and things like that. So it's something of a hassle, actually. So imagine that instead of 2 places I want to find the square root, I really want to find 20 square roots. Well, I could cut and paste that code and make those changes, but you're probably thinking, wow, I hope that's not the way we always have to do it. And you'd be right. Now, some things I could do while we're here is say, well, I could have literally just taken this code right here, cut and paste it down here, and changed a to say 17. Then I wouldn't have had to make the updates. Sure, I could have done that. But what if I need to keep a as a certain value and I don't want to reuse a? Well, then I've got issues. So the solution is create functions. And functions are where we take some piece of code and sort of package it up to where I can use it. So why do we use functions? Well, one, it makes the general purpose of the program easier to follow, because I can look at the function calls and understand what's happening as opposed to looking at all the code that does what I have to do. Another benefit is it reduces the number of places to update. Let's go back to here. Even though I said, well, one solution to making this easier might be to take this code right here, cut and paste it down, and simply change a to be 17. But if for some reason I need to keep a and x separate in each place where I use the square root, well, then I do have to use separate variable names. And so that means I have to make those changes in every place. That's not really making the code easier to reuse, which is one of the benefits of it. And also, what if I wanted to make a change to how it works? What if, even though this works correctly, what if I said, well, I have a different formula I want to use that's better in some way? Well, I got to fix it here, I got to fix it here, I have to fix it every other place that I use it. So that's a problem. And then another benefit, which is not necessarily a problem for independent programmers, but if you're working with other people, is you want to hide the implementation, letting the programmer focus on the functionality. So what I mean by that is, let's say I'm writing some code and you're also sharing some code that I'm using, or it may just be me using this as part of some other program. And I'm calculating something along the way, and maybe I say, well, I need to use this particular calculation anyway, so I'll just use the one that you threw in there when you were calculating the square root. Well, now my code that may have nothing to do with calculating square roots is tied to the calculation of the square root. Because now if you come back and change your method for finding square roots and you don't produce that intermediate result that I'm using because I needed it, you break my code. So either you don't make a change so you don't break my code, which means you can't improve your own code, or you improve your code and break my code. So it's better just to say that we essentially have like a contract. If you're the one writing the square root code and I need to use it, I say, okay, I'll give you the number to find the square root of, a in this case. You calculate the square root any way you want, and then you give me back the square root, and I won't try to look at what it is you did. So it has that benefit as well. So how do we write a function? Well, we use the def keyword. We have the name of the function, and we have 0 or more input values. Some functions don't receive anything, so there might not be anything here. And then we indent to represent the body of the function, just like we did with the conditionals and loops. And we put our code that's being used when the function is called. So here's a function that simply receives two numbers, A and B, adds those together, and then it returns the sum of those two numbers. And so this is a function. That's all it really takes. So a couple other things to know. The variable names in the function definition don't need to match the names in the function call, but at least in general, the quantities should be the same. There's actually exceptions in Python that I'll probably gloss over for right now. So what do I mean by that? Well, if in your code where I called add numbers, maybe in the function call, I said add numbers X and Y. Well, here it's referred to as A and B within the function. They don't have to be the same name, which is also one of the benefits, because now I have the freedom to use variable names outside the function call, or outside the function definition, that I will use as part of the function call, and then you're free to do what you want right here. If we want to return something, we use the return keyword, but we don't have to return anything if we don't want to. Within the function, you can pretty much do everything you would have done if you weren't using functions. But one of the things to keep in mind is that variables in general that are created inside a function are not known outside the function. And so it's a concept known as variable scope. So the variable scope has to do with where is a variable known. So that means if I was using this code right here, and then outside the function call, I tried to use A or B, and there was no existing A or B created outside of this, then the computer wouldn't understand what A and B were, because it's sort of a package, right? So where do you put your function definitions? Python gives you a lot of freedom over where you put them, including right in the middle of other code, but I personally don't like doing that. So I prefer to put the function definitions at the top of the rest of the program. And one of the benefits of that is that since the programs or the files are processed from top down, well, then they're seen before you make the function call, and then therefore they're known at the time of the function call and things work. If I were to take this code right here and put it at the bottom of this file, then when the Python interpreter, that's the program that reads the logic here and does what it says, when it encountered my square root before it saw the definition, it would not know what that meant and would give me an error message. So here I've created an entire program. I've created a function called my square root. Here's that logic that I had before. There's the threshold, the initial guess for X. Here I call N the value that I passed in, whereas A is what I'm using to pass in. Here's the logic, and then once it gets the answer, it returns X, which now I've assigned to another variable called X. These don't have to be the same either, and then it prints a result. So let's see some variations on this. So here's that logic, and let's run it. So here I create A, something called X. Like I said, they don't have to be the same X. I can prove that if I want to. We'll call it Y. I'm just doing a search and replace to make sure I find everything. Let's see if it still works, or if I broke it. All right. So the first case is one of the simplest uses. A is 25. We know the square root of that should be 5. I pass it to my function. It returns its answer, Y, and then I print it. It says the square root of 25 is this number right here. Why isn't it 5? Well, it has to do with how close I want to get in my threshold. The smaller the threshold, that means the bigger the difference can be between what I think the square root is and what it really is. So let's say it's this. See this number, see now, the 2 versus a 0. So this number is farther away from 5 than this number. If I want to improve it, I can make the threshold really big. That means you have to keep getting closer and closer to what you think is the square root. Because ultimately, now in this case, it is an integer. But if I was trying to find the square root of an irrational number, then it never terminates. So I'm never going to be able to get an exact answer. And see now, at the level of precision it prints, it says it's 5, but internally it still may not be 5. Right? That also had the benefit of improving this, which is now 22. So let's see another way to use it. Well, here I put it as part of another expression. So 17 plus the square root. So I get the 5, and I take the 5 and add it to 17 to get 22. And so we see that y is 22. Let me clear this to make it easier to see all this. And now I'm going to put the call square root into another call square root. So how does that work? So I have this right here. So remember, we have a is equal to 5. And so when I say y is equal to my square root of my square root of a, this is evaluated from the inside out. It can't tell me what this is without knowing what this is, right? So to evaluate this, it plugs in the 5, and so it gets, or excuse me, the 25, that's what it was, plugs in the 25 and gets 5. So this reduces then to y is equal to my square root of, so this right here is going to be 25, makes this here 5, and then we get y is equal to, it was 2.24 approximately. Right? So that's how it works. So it's just like when you do other things with parentheses. If I had x is equal to this, 1 plus 2 plus 3 plus 4, 1, 2, 3. How do we evaluate this? Well, I don't know what to add to 1 until I evaluate this. Well, I don't know what 2 it needs to be added to until I evaluate this. So this becomes 7. So I get 2 and 7, right? So this expression becomes 1 plus 2 plus 7, which becomes 1 plus 9, which becomes 10. This is the same type of thing. So I could keep embedding function calls there and getting square roots of square roots of square roots if I wanted to. Right? So it's really that simple. But certainly, as we've seen here, I had 3 different uses of the function. Technically 4, actually, because there's 2 right here. So there's 4 calls to my square root function, but I use the same exact code every time. Also note, this isn't necessarily what, this is a comment, right? But I like to do this because to me it makes it much more clear where the program starts. In fact, I could write this. This is where the program starts. Without this, then if I'm looking at this, I mean, it still works, of course. But when I'm just looking at the code, it doesn't jump out at me as being obvious this is where it starts, because I might have lots of functions. So I like to do this, or technically this, to make it much more easy to identify where everything gets started. So we said that we can pass things to functions, but we don't have to. And we can return things from functions, but we don't have to. So that leads to 4 combinations. So in this one, option number 1, I don't pass anything to the function. So the definition looks like this with empty parentheses. And I don't return anything, so there's no return statement. So when this function is called A, it simply prints inside the function. So this is perfectly fine. This is the function call. It gets here. It prints. We're at the bottom of the function. The flow of the logic returns back to here, and we continue down. Now in option 2, I don't pass anything in, but I return a value. So value here is equal to whatever B returns. So we call B, we get to here, it returns 99. Value is equal to 99, so it prints 99. Why would you do something like this? Well, there's functions for generate random numbers. So you might do something like this, like x equal, it's in, I think in Python it's random. So you might do something like this where you don't give it anything, but it gives you back a random number each time you call it. So it is possible to do things like that and have some practical use to it. So that's two of our options. Our other two options are these. Here I pass in x, 25, and in this case it just prints x, but doesn't return anything. And finally, in the fourth option, we pass in 33, and it returns 2 times 33, so this would print 66. So every one of those four options has some purpose. And of course here I'm just showing you one thing being passed in, but we could pass in 2 things or 3 things or 10 things or other types of objects. We haven't seen other data types much, so I'm somewhat restricted to working with numbers here, but we do have those options. So I said earlier that the math library has its own square root. How do we use it? One of the things that makes Python very popular is it has a huge library of functions. So there's basically a function for everything. So I've written programs to email people their grades when I taught programming classes. Well, I'm not an email expert in the sense of how do you really connect to an email server. So it was nice that they had a library that I could call to form a proper email and then contact the mail server. I've written programs to do other types of things that I was an expert on, like read images and display the image. Well, I don't have to understand how to read a JPEG or a PNG file or whatever. People have already written libraries to do those things for me. So if I want to use the math library, what I need to do is import that library. And so you see now, to use their square root, I say math.square root. And so this would pass in 49. And so ultimately I'd print the square root of 49 is 7. That's how it works. So that's really all there is to functions. So going forward in the videos that I'll create after now, I'll start using functions for things because it will make lots of things more readable. So before we start this video, let me show you a program I wrote quite a few years ago. We're not going to go into all the details. And also keep in mind this is a Python 2 program, so it wouldn't actually run using Python 3. But the point is to show you a larger program. So you can see here I wrote it almost 10 years ago. And what it does is it performs classification. So I downloaded a bunch of documents that were from what are called news groups. So news groups aren't really that popular now, but basically it was like the Reddit of its day. People could go in there and they could discuss religion or politics or sports or animals or whatever. And it wasn't necessarily a forum. I think it was actually more like you interact with it almost like emails, although it wasn't quite the same as email. But you had to have like a news group reader and that type of thing. But anyway, there are some online data sets you can download that came from those news groups. And so this program I wrote would look at the words that were contained in the different documents and try to put them into groups where similar things were grouped. So for example, if I saw a bunch of documents that had the words referee and shortstop and baseball, well, those are about sports, right? So you'd expect those to be similar. And if I saw a bunch of documents about, monkeys and giraffes and elephants and stuff, well, those are all about animals. So maybe those group together. So what I do to write the program, let's see how big it is. 340 lines of code, right? So it's not small, at least not by the standards of anything we've written up to now. It was too big for me to try to work it out all in my head. So what I did was I started off with my pseudocode. And so I said, okay, I need to read the training data. So I need to get those files. And for each file in the training data, read the file, tokenize. That's something we haven't talked about yet, but basically get the words that were in the document and save them. And then for the list of words, I need to determine what the unique words are. And then for each set of words, produce a term feature vector. Basically, it was a vector containing what words were there for a particular document and so forth. But these are high-level descriptions of things, right? And then when I needed to test, I did a lot of the same things. So when I was testing, because I used this part to train the system, I gave it examples of documents, and then I used what it learned to try to classify new documents. And so it had to go through a lot of the same process. So now you had to read the testing data and tokenize and do all these things. So look at what I did. Think about what I just have here, and now let's look at the bottom of the program. That basically became a bunch of function calls. Here's the main. So here's where I'm getting the name of the data files. And what was the first thing I do? Process files. What was the top thing? For each file of training data, read the file and tokenize. In fact, let's go look at what process files does. So here's the function call. It's right here. And it could have its own pseudocode. In this case, it doesn't. But there's what it does. It gets the file, a list of files. It goes through each one and opens it. And I'm doing lots of things we haven't covered yet, so don't worry if you don't follow this. But then basically it's doing the tokenization that I mentioned earlier, and it returns a list of tokens. Save list of words, which are the tokens. So then for each list of words, read the words and update a unique words list. Get unique. So it takes the output from this function and makes it the input from this function. And then this and this, or excuse me, this and this became input to this function. So let's look at this one briefly. Get unique. So here I have pseudocode, and I will tell you another nice thing about Python is the readability of code compared to some other languages. Some people have compared Python code to be like executable pseudocode. That is, it's somewhat readable, but it actually works. So here's my code for getting the unique terms, and I took my pseudocode and turned it into actual logic, which is very similar, and then I returned the list of unique terms, and so forth. Create vectors. And so I use process files here, I use it again. Create vectors, use it again, and so forth. We'll look at one or two more of these and then move on. So here I've got pseudocode. So here's this function, and there's the logic. So, of course, I have a lot of text in here that is documentation. This right here, I don't have to have this here, so the computer doesn't care about this. I do this so if I look at it or you look at it, I can understand what's happening. But do I need to create functions for this? No. Instead of having this, I could have taken all the code in the functions and pasted it right here. But that means when I did whatever this is, I would have had to reuse it here. And whatever this is, I have to reuse it here, and so forth. And it would be a lot harder to read. But now I can basically read it, process the files, get the unique terms, create the vectors, build the classes, which is the groups. So there's a sports class or a religion class or an animals class or a cars class or whatever. And here's the same type of thing. And it's basically just taking this pseudocode here and turn that into a function call, turn that into a function call, that into a function call, and so forth. That's all there was to it. And then here's where I'm importing some of the libraries I want to use. The file globbing library, the string library. We haven't talked about these things yet. But that's all there was. But I would not want to have taken this and taken that code and that code and that code and that code and so forth and pasted it down at the very bottom. I wouldn't want to do that and try to follow the logic, especially if I mess something up. So hopefully you can start to see the benefits of using functions. Now, how do you know what should be in a function? It's a matter of opinion, all right? I can tell you some people do this. And I think it's probably okay in the beginning, but it's a bad thing to do forever. So let's say you do this, and you do something like this. A is equal to 3, B is equal to 4, and C is equal to 2 times 3 plus, 5 times, sorry, this should be 8, right? And then you do something like this, you say, you find yourself doing stuff like this, cutting and pasting. Let's see if that works, actually. You find yourself cutting and pasting, or at least I do, and I think, oh, wow, why don't I just put that in a function? So you come back up here, def, we'll just call it f. So we'll call it x and y here. We could call it a and b actually, it doesn't matter. Now, should I print from here? That's debatable. Think back to my square root example. I could have put the print statement for what the square root was inside the function call, the function itself. But then in places where I want to do something like this and say x is equal, I think I had an example, I said x equals 17 plus my square root of a is what I had. Well, if I put the print statement up here, now things aren't going to work right. It still would work, except now if I was going to print from up there, I wouldn't return anything, so it wouldn't technically work. But in this situation, I wasn't interested in printing the square root. I was interested in using it for something else. So had I simply had the print statement up here and not return something, I'd be limiting the usefulness of the function. So you have to think ahead of those things. But there are other times you'd want to do that. So let's say we did something like this. Right? This one wasn't bad. There weren't really a lot of mistakes. And you may be thinking, well, geez, why did he do all that? Is that any better? Well, what if I said, whoa, I made a mistake. I wasn't supposed to be using 2. I was supposed to be using -2. Well, now I fix it in one place and rerun it. But what I was going to get at earlier is that when you write your function down here and then decide to, or write the code that ultimately will be in a function, and then ultimately put it into a function, the problem you get into is if you have lots of other variables and things going on, it becomes difficult to extract the parts you need just for the function from the other parts. So I always use the analogy of letting a vine grow in a fence. The longer you let that vine grow in the fence, the harder it becomes to disentangle the vine from the fence, and that can lead to problems. So it's better to think about your functions ahead of time and think, what is the input, what is the output, and then write the logic for it. Although I do admit that I do sometimes do what I just demonstrated, which is I start off not thinking I need a function, and then I realize I'm doing the same thing over and over again, so I turn it into a function. Right? So that's our function discussion. So in the ongoing videos, we'll probably start using functions a lot for readability and code reuse purposes.